This is the Unit 6 review for Math 7. So the first thing we learned in Unit 6 involved solving equations. And we learned a bunch of different ways to solve equations. We used hangers and we used scales. Just thinking about our equation always needs to stay balanced. So when we are solving an equation, the first thing we want to do is if there are parentheses, we want to eliminate the parentheses. And we can do that by either distributing or dividing the number from both sides. After we do that, then we undo any addition or subtraction by doing the inverse operation, which would be the opposite of addition or subtraction is subtraction or addition. Then we undo any multiplication or division. So let's take a look at this first problem. We have 2x plus 15 equals 41. So what we are going to do is first, there's no parentheses, so we're going to get rid of the addition. The opposite of addition is subtraction. So we've got 2x equals 26. Now, after we get rid of the addition by subtraction, we need to get rid of the multiplication of the 2 on the x. So the opposite of multiplying by 2 would be dividing by 2. But whatever I do to one side, I must do to the other side. 26 divided by 2 would be 13. Now we have x all by ourselves, so we have got the answer. We can check our answer by plugging it back in. 2 times 13 is 26. 26 plus 15 is 41. So it checks out. The next problem, B, we want to get rid of we need to get rid of the parentheses first. So right now my parentheses are being multiplied by -3. So the easiest thing is to divide both sides by -3. That cancels that -3 out and we are left with x minus 4. And then -9 divided by -3 is 3. Then the last thing is we need to get rid of the subtraction. So here I am subtracting 4. The opposite of subtracting 4 is adding 4. So I'm going to add 4 to both sides. That gets rid of that 4, and we are left with 7. X equals 7. Now, all of these are using x, but we don't necessarily have to have x for our variable. Our variable can pretty much be anything we want it to be. All right, the last one here, -1/2 x plus 4 equals 1. So the first thing we want to do, there's no parentheses, so we're going to get rid of that addition by subtracting the 4 over. So 1 minus 4 is -3. Then I want to get rid of the multiplication of -1/2. So I'm going to divide both sides by -1/2. And we can use a calculator for that, or we can change the division to multiplication, which gives us 6. So there is our answer. So when we're solving equations, we get rid of parentheses first, then get rid of addition or subtraction, and then get rid of multiplication or division. Okay, probably the hardest part of this unit is solving the inequalities. When we're solving an inequality, think of it as solving an equation. There's just one difference, and that is if you multiply or divide any inequality by a negative, we must flip the direction of the inequality. And that is because anything that was negative became positive and anything positive became negative. Then once we solve the inequality, we just put it on a number line and we check our regions to make sure we graph the right region. Also, here is a little list, and it's on your paper as well. All of the symbols, we have greater than, that's an open circle on the number line. Less than is also an open circle on the number line. Less than or equal to is a closed circle on the number line, and greater than or equal to is also a closed circle on the number line. So if we are going and we are trying to solve the inequality, the first thing we want to do is solve it like an equation. So I'm going to subtract the 3.5 from both sides. So then I get negative 1.75 n is less than 1.75. And then we are going to divide both sides by negative 1.75. The trick is, though, since I'm dividing by a negative, I have to flip the direction of my sign. We have n is greater than negative 1. So we're going to take that. We're going to put negative 1 on the number line. Because it is just greater than, it's an open circle. And according to my n is greater than negative 1, it's everything that's going to the right. But I am just going to check to the original equation, just to double check. I'm going to pick a value to the right of 1, negative 1. So let's pick 0. 0 is to the right of negative 1. And I'm going to go 3.5 minus 1.75 times 0 is less than or equal to 5.25. Is that true? So 1.75 times 0 is 0. Is 3.5 less than 5.25? It is. So we've got the right region. And the answer to an inequality is the n is greater than negative 1 and also the number line. We can interpret this as the solution is all the values greater than negative 1. If we were going to try the other problem, we've got 4x minus 1 is less than or equal to 20. So I'm going to solve this like it were an equation. I'm going to divide both sides by the 4 to get rid of the parentheses. And since that is a positive 4, we do not need to change the direction of the inequality. Then we add 1 to both sides like we were solving a regular equation, and I get x is less than or equal to 6. Okay, we put that on a number line. Here's 6. We can be equal to 6, so I'm going to close my circle. And x is less than 6, are all the values less than 6, so we're going to go to the left. Let's pick a value less than 6. Let's pick 0. 0 is less than 6. 0 minus 1 is negative 1. 4 times negative 1 is negative 4. Negative 4 is less than or equal to 20. So once again, our solution is this inequality and the number line as well. Okay, one of the hardest parts of solving inequalities are writing word problems into inequalities. So we're going to take a look at this word problem, and I think the easiest thing is to kind of start by highlighting what is given to you. It says, at midnight, the temperature in Salt Lake City was 23 degrees Fahrenheit. So that's our starting value. Then the temperature dropped 3 degrees each hour. We need to write an inequality that represents t, so my variable is t, the number of hours past midnight, so t hours past midnight. Then the inequality needs to represent when the temperature was colder than 14 degrees. So colder is less than, it's smaller than. So let's look at this. We're starting at our starting temperature, 23 degrees. Then we are subtracting 3 degrees each hour. This right here represents the temperature at any given hour. So it's our temperature at time t. We want to know when that temperature at time t happens to be colder than 14 degrees. So when is this colder than 14 degrees? That would be when our temperature is less than 14, because colder than is less than. It doesn't say colder than or equal to 14, it says colder than. So we are only going to use the less than. This is the actual inequality that they are looking for us to write. Now, the next thing we need to do is solve this inequality and put it on a number line. So I'm going to start by subtracting 23 from both sides. I end up with negative 3t is less than negative 9. Then, to solve this one more step, I need to get rid of that multiplying by negative 3. The opposite of multiplying by negative 3 is dividing by negative 3. So t ends up being greater than 3. I did one thing. I switched the direction of my sign because I multiplied or divided by a negative. So that means t is greater than 3. On a number line, that would look like, here is 3. It's an open circle because we're not equal to 3, and where the value is greater than 3. So that means at 4, 5, and 6 hours after midnight, we are greater, or we are less than 14 degrees. And any time in between. So one thing to kind of consider here is the actual wording of how our answer would be. And I would say the temperature is colder than 14 degrees after, 3 hours after midnight. So there we go, at 3 o'clock, 4 o'clock, 5 o'clock after midnight. So that is the word problem. It's kind of a tricky word problem. These are the hardest things. These inequalities are tricky, and then putting them into a word problem is a pretty complex thing, but I know that you guys can do it. The next problem is adding and subtracting expressions, which is a very easy, fun thing to do. You just need to add like terms. So we look for our like terms in our problems. The two things in purple, the 3x and the 5x, those are like terms. So here we would go 3x plus 5x. And then the green are like terms. So there we would go negative 9 plus 15. And if we do each of those, 3x plus 5x is 8x. Negative 9 plus 15 would be plus 6. Same thing on the next problem. So we're going to find our like terms here. We've got 10 and the 13 are like terms, and the negative 6 and the 2n are like terms. So we're going to start by going positive 10 plus 13 happens to be 23, and negative 6n plus 12n is positive 6n. So there is our combining like terms, or simplifying the expression when we just have addition or subtraction. All right, distributing is the next thing in this section. So to distribute, we're essentially just taking the number that is out in front of the parentheses, and we're multiplying it by everything inside the parentheses. In this case, I'm multiplying it by, an x, a plus 9y, and a negative 17. So we are just going to go 5 times x is 5x, 5 times 9y is 45 plus 45y, and 5 times negative 17 is negative 85. So our actual distributing is the answers inside my area model. That's our answer. And it works no matter how big or small the number is. So let's look at this next one. Or how fractiony the number is. We've got -1/5 out in front. And we have -15 inside the parentheses and +25 inside the parentheses. We're going to go -1/5 times -15 is 3x. And -1/5 times +25 is -5. So the distributing of the -1/5 through the expression -15x plus 25 ends up giving us 3x minus 5. When we are factoring, we are doing the opposite of distributing. So we are trying to find the number that divides in evenly into both terms. This number is in front of the parentheses, okay? And then we divide each term to find what goes inside the parentheses. So if we look here at the first question, 18a plus 12. We want to factor that so that what goes into 18a and +12? Well, if we find the GCF between 18 and 12, we get our GCF is 6. 6 divides into 18 and 6 divides into 12. So the numbers that go in these next spots are found by taking 18 divided by 6 is 3, carry up the variable, and 12 divided by 6 is 2. So that's a +2. We keep the sign the same. Then when we write the factoring, we just use those same values. The 6 goes in front. What's on top is what is in my parentheses. The next one here, 7x minus 49. We have 7x and -49. So the number that goes in front of there is the LC, or the greatest common factor between 7 and 49, which is 7. And then 7x divided by 7 is 1x. And 49 divided by 7 is 7, but we're going to use the sign that is on there. So we have 7 times 1x minus 7. And there's our factoring. And that is it for Unit 6.